everyone, and welcome to this Nokia webinar, Cloud Native Appliances Scaling to 5G Edge Performance. Today, we're diving into the exciting world of Nokia 5G Cloud Packet Core and introducing our cloud native-based appliances. Let's examine how it's leveraging cloud native architecture and the power of AMD core processors to deliver exceptional performance and efficiency. We will be exploring how this innovative combination is transforming the way we think about network infrastructure, enabling operators to deliver a superior user experience while minimizing their footprint and their energy usage. My name is Shelley Schluter, and I will be your host for today. I'm thrilled to have three experts in the field of cloud networking and high-performance computing joining us for a discussion. First, we'll have Ruth Brown, Principal Analyst for Mobile Networks at Omdia. Ruth's key coverage areas include system architecture, core infrastructure and services, and supporting cloud technologies. Piotr Weglicki is a global telco lead in AMD server business unit. Having spent his career in the semiconductor industry in CPU and application processor technologies for the telecommunications sector, Piotr brings a strong technical foundation and understanding of network and telecom systems, as well as a strategic perspective on market dynamics and innovation in the telco space. Our third presenter is Gordon Milliken, Head of Packet Core Product Management at Nokia. Gordon brings extensive experience in the design and implementation of cloud-native network solutions to the table. He will be sharing insights into the architecture and capabilities of Nokia Cloud Packet Core. Together, these experts will provide a comprehensive overview of this innovative solution and its impact on the future of telecom networks. So, our chat window is open for live questions, and if we can't answer them during our discussion, we will send you the answer later. Let's go ahead and get started. So, Ruth, I'm going to start with you. Our 5G services are demanding high capacity, robust performance, and low latency at the edge. Can you please give us your view of market trends and expectations for this segment?
Yeah, absolutely. Well, thanks very much, Shelley. It's fantastic to be here with everyone today. So I think in terms of the changes and the differences between 5G services, so we've really seen expect changes of the services change in this generation compared to previous generations. So we've got, more demands for higher network capacity, performance, and much lower latency. And this is particularly good in terms of, edge, using the edge applications. So operators and enterprises are starting to invest in compute and intelligence, so it's closer to the edge. And this is where they can use these sort of real-time responsiveness. And it really supports these services that I've spoken about and their new demands. In terms of the types of services that are really going to be of interest for edge compute, so Omdia's CSP Edge Computing Survey for 2025 talks about a number of different use cases and technologies and what's driving edge investments. So the first and number one use case driving edge investment is the 5G core itself, so 5G SA. This is really a major catalyst at the moment in terms of investments at the edge. We've seen operators modernizing their networks, trying to be more agile and increase automation there. Next use case in terms of investment is private networks. This is obviously a really hot topic for enterprises looking to localize control and performance. And then AI, which is probably not a surprise to people, we're seeing a much more of a growth and interest in terms of investing for AI. So this is investment in sort of the processing and inferencing for workloads. And these really all thrive in this kind of edge, low latency processing environments. Obviously, there's a number of other opportunities and use cases across industrial IoT, real-time applications such as VR, XR, gaming, and also these communications, things like translation. And not to mention VRAM, which is still quite an important edge use case. And again, these rely on this sort of co-location of data processing close to the source and also the lower latency. So if we look ahead really to consider, other aspects such as where applications should reside, we're also seeing a conversation and an interest happening in the moment and interesting about where it should be. So should it be on the edge, the device, or in the cloud? So we're seeing quite a lot of innovation in terms of device level AI. We're also seeing this move towards hybrid models where intelligence is much more distributed. So some functions handled directly, maybe on a device, either for speed or privacy. Others might be placed on the edge, which is still secure, but maybe offers some kind of edge benefits or cost benefits, and then some towards the cloud for sort of scale coordination. So really, it's in terms of establishing the best location and the best way to process the data and applications in terms of performance and latency, security, and also efficiency. We're also seeing opportunities for the edge arising in terms of national security use cases. So, there's been a big drive in terms of the data set sovereignty opportunities coming up. So that's another consideration we're seeing. So if we move from, talking specifically about the use cases and now onto the actual physical edge compute considerations, the edge environment has a lot of demands around these sort of lower footprint servers. So servers that are able to have, space, power, and energy efficiency. So space is often can be quite small or short at the edge. So these are really high priorities. And especially as we see the 2030 targets coming for sustainability, being able to hit these energy efficiency targets is really, really important. Another quite high priority aspect is the support of co-locating multiple applications into these sort of smaller single servers. So we might be seeing a co-location of CDNs, firewalls, AI, and even distributed UPF on a single chassis. Finally, people are still interested in the support and management of these services. So opportunities around managing these resources remotely and also being able to cover sort of service assurance. So really, I guess in terms of where we are with the edge, it's evolving quite rapidly, even compared to a few years ago. We're seeing it wanting to become more advanced, more intelligent, and there's more demands in terms of being energy efficient with the actual compute layer.
Excellent. Thank you so much, Ruth. Well, Gordon, now we're going to shift over to you. We're now bringing the cloud to the network edge with our cloud native appliances. Could you please tell us what the benefits of a cloud native appliance are and what CSP needs it addresses?
Hi, Shelley. Thanks for inviting me to this really compelling discussion. First, let me start by breaking down the benefits of these new cloud-native appliances, both the appliance as implemented at the edge in our smallest form factor, as well as the whole portfolio, and how they address key service provider challenges. Cloud-native or CNF-based appliances combine the best of both worlds, the performance efficiency of traditional appliances with the operational agility of cloud-native technology. Both of our existing VNF appliances and now our new cloud-native appliances deliver exceptional performance and efficiency benefits, including dramatically reduced power consumption of up to 75% less than traditional telco cloud stacks, exceptional throughput capabilities, like Nokia's latest CMG A2, delivering over 400 gig of throughput with just 2 servers. That's with 100% DPI and NAT, much more, of course, in FWA configuration, where we optimized hardware utilization with minimal operating system overhead and a compact footprint that's ideal for edge deployments. We're taking the performance gains that we achieved through our partnership with AMD on the VNF appliance and extending them to give new CNF appliance to our new CNF appliance portfolio. Beyond performance, these solutions provide significant operational agility through in-service software upgrades, ISSU, that eliminate downtime for updates, seamless integration with existing automation and CI/CD pipelines, rolling updates with Canary deployment strategies, and auto-scaling capabilities through Kubernetes. They also offer enhanced observability through native integration with industry-standard tools like Prometheus, Grafana, etc., enabling better monitoring, visualization, log management, improved troubleshooting, and performance optimization. These capabilities directly address several critical CSP needs. First, at the small, low-capacity end of the portfolio, they solve the edge distribution challenge where CSPs need to push user plane functions closer to the edge for 5G SA services. But traditional telco cloud stacks are too heavy and expensive for edge locations. Small, low cost, either single server or dual server cloud native appliances provide the compact, easy to manage design needed for these deployments. They enable significant cost optimization through reduced power, space, and cooling requirements, lower operational complexity, especially for remote or customer premise deployments, and better resource utilization and efficiency. Perhaps most importantly, they provide operational consistency by allowing CSPs to use the same Kubernetes-based management tools across their entire network, maintaining operational consistency while optimizing performance where needed, rather than managing different systems for core and edge. Finally, these appliances offer future-proofing since the existing VNF-based appliances can be evolved to this cloud-native model through a simple software upgrade with no hardware forklift required. This approach essentially gives CSPs the performance they need for demanding user play and applications while maintaining all the flexibility and automation benefits of cloud-native operations.
Thank you, Gordon. Flexibility is such an important part of these things. So Piotr, now I'm going to turn to you. AMD has been a great partner. Our close collaboration made cloud-native appliances a reality. Can you please tell us about the latest AMD technology that underpins this new solution?
Thank you, Shaylee, and we are very excited about the collaboration with Nokia and technology that we jointly bring to the market, to the service providers. So the latest AMD technology powering Nokia Cloud Native solution is the 5th generation EPYC processor, 9005 series processor, which has been implemented both in cloud mobile gateway appliances and also in Nokia Cloud Platform. And this is part of our strategic collaboration between the two companies. So the 5th generation processor, codenamed Turin, is based on our latest state-of-the-art CPU technology, Zen 5 and Zen 5C. And it brings unprecedented level of integration and compute density. In this product line, we are bringing the entire family of products going from 8 cores up to 192 cores, physical cores, which makes up to 384 virtual CPUs, which is a huge number. And it's very important really for some of the applications, especially for the packet core. It's not only important to bring the entire high density compute solution, but also a well-balanced system, including a high memory bandwidth and also high I/O throughput. And we bring these capabilities to the Turin devices. We've been really driving the edge and leading edge security solutions. So we are bringing the confidential compute and also trusted I/O technology to this technology as well. So this CPU is very well suited for the packet core because of the right combination of the compute performance and compute density, memory bandwidth, and also I/O throughput. the compute density is scaling nicely actually with the UPF performance, and that's a very important aspect of that. But also getting the right performance in terms of a memory bandwidth and I/O throughput is absolutely crucial as well. The compute density has a very big impact, because if you can put in a server more processor cores and achieve a higher performance per server, the operators can reduce the number of servers that they are purchasing for the specific implementation of a packet core. And what it means is, by this, they're reducing the CapEx, and also they're reducing the OpEx. Lower cost of purchasing the servers, but also lower energy cost as well, because of these lower number of servers as well. And then brings the significant savings in the total cost of ownership. Now, the performance is absolutely key in bringing up the solutions here. And we've got a huge, across different workloads, we bring a huge performance increases versus previous generations. But one thing that I wanted to bring to attention is the performance that the operators care about, which is the throughput. And, I don't want to bring, to steal this thunder from Gordon, but, you will see in his slides that going from the 4th generation to the 5th generation of EPYC, Nokia has managed to get the performance increased by 80%, which is absolutely massive.
Thank you so much, Piotr. That's a lot of savings. Very impressive. So Ruth, I'm going to come back to you now. As operators converge cloud-native software with purpose-built edge platforms, what's your perspective on CNF-based appliances and their fit for today's market demands?
Yeah, absolutely. So, Piotr and Gordon have spoken quite a lot about the physical and performance capabilities, but we're also seeing this major shift towards cloud-native appliances, a massive transformation. So that's really changing the way how the networks are being built and deployed. So initially, I suppose, service providers relied on virtual network functions, especially for sort of UPFs, which were, needed these high requirements quite often. And we're now seeing that these kind of flexibility that they're able to offer, sort of the VNFs were, compared to sort of physical network functions or appliances. But now we're also seeing this kind of rapid transition and evolution towards being able to support them now as cloud native functions. So applications designed from the ground up, they're running in sort of cloud native environments using containers, microservices, and orchestration tools like Kubernetes. And I think previously, when we first saw the original generations of 5G, we couldn't, especially in the UPF, get the performance requirements, especially in these CNF implementations. If we look kind of to see what the industry is saying, so Omdia's got a 2025 service provider core network survey, and this actually tells us that by the end of 2025, we expect to see about 60% of operators deploying 5G CNF. So this is a massive transition to moving this sort of cloud native functions. And I guess, why are they making this move? There's several top reasons, operational simplicity, CNFs are streamlined in terms of deployment, they can scale very easily, life cycle management. And there's also sort of the ability to reduce the time and effort needed to launch or update network services. So this is really important. We also see within cloud native architectures, there's better resource management and automation. So dynamic allocation of compute storage. And this is really driven by these sort of intelligent orchestration and automation that are starting to evolve. We also see that, isolation and security, it's huge. Containerized functions are able to provide these stronger boundaries and resilience across workloads, and the performance stability. So modern CNFs, I sort of spoke about previously, they didn't have this performance, but they're now optimized to be, predictable, high performance operations across sort of hybrid and multi-cloud environments. So really these benefits enable operators to deliver much more agile and efficient and also reliable networks. So definitely supporting 5G, supporting edge, supporting AI applications. So if we look specifically to the edge hosting requirements, typically the requirements are quite strict. And by that, I mean, space for servers is normally, can be relatively small. So footprint and size is really important. I think Gordon sort of spoke about this. And it really directly relates to sort of hardware cost, space, power and cooling as well. So therefore, the Pietro already spoke about, these new compute coming in, which are much higher density. This is becoming much more important to operators so they can deliver, the same functionality or much better in a much, much smaller form factor. So this is like really important. The other key thing, going back to sort of the way in which the cloud market trend is going. So Omdia's sort of cloud network tracker is also projecting there's going to be a massive growth really around the growth towards telco network cloud market is going to grow by 12%. So this is really broadly driven by this move to these cloud architectures and using appliances or going from appliances to these sort of cloud native functions because they're now able to support this much higher performance. And it works really well in terms of sort of the costs and efficiencies that I spoke about before.
Excellent. So we're seeing lots of efficiencies across the board, it sounds like. Now, Gordon, Ruth just talked about market demands from her perspective. Could you share your insights on what the market expects in terms of network performance and how cloud-native appliances are helping CSPs? And are there any use cases in particular that you want to highlight?
Well, Shelley, frankly, I want to echo everything that Ruth just said. The market is really demanding a fundamental shift in how network infrastructures operate. And what we're seeing is that communication service providers, CSPs, need solutions that can deliver both exceptional performance while being incredibly flexible and cost effective. And that involves all the points that Ruth made. So stepping back for just a moment from our appliance discussion to our Nokia Cloud Packet Core, in particular, we've designed our cloud native approach so that it's directly addressing these market expectations by offering CSPs unprecedented deployment flexibility, whether they want to deploy on-premise, so for instance, in an appliance, in private clouds, or even in hyperscaler environments, and up to and including a large CSP cloud infrastructures. Working with our partners, AMD, and again, maybe shifting back now to appliances, in our VNF appliance, we've been able to unlock incremental performance by mapping our product architecture to the innovative chip design. This was possible in VNF appliances through things like core pinning and being very specific about where we deployed our service virtual machines. But now we're extending that performance partnership to our infrastructure partner, Red Hat, in order to achieve the same kind of core performance improvement, even in cloud deployments. So we get the advantage that we learned through our VNF-based appliance program, extend that in our CNF-based appliance program, and now can even achieve that same performance enhancement in traditional large cloud deployments. What's really exciting and new is how this enables CSPs to distribute user plane functions right at the edge, which unlocks entirely new service capabilities that go far beyond what we could see back in 4G days. We're talking about supporting everything from private networks with advanced slicing and SLA guarantees to ultra-low latency applications like AR, VR, and Industry 4.0 use cases. The performance numbers speak for themselves. We're delivering hundreds of gig per second from a single server while using up to 75% less power than traditional telco cloud stacks. This isn't, however, just about better performance. It's about fundamentally reducing operating costs, minimizing space and cooling requirements, and providing a lower total cost of ownership. What makes this particularly compelling for CSPs, and now I'm referring to our CNF appliance portfolio, is that they can translate seamlessly from their existing VNF-based systems to our CNF-based appliances through simple software upgrades, protecting their current investments while positioning themselves for the innovations that we're bringing to market next year.
Thank you so much. Okay, well, Piotr, we've talked about AMD a few times already in Gordon's presentation. So with the exponential growth in 5G and edge computing, how is AMD positioning its technology to meet the evolving demands of future cloud networks?
So AMD is a high-performance computing company, and we'll continue to channel our innovation to bring to the market solutions with ever-increasing performance, but also the very important factor is to really improve the energy efficiency and provide the scalable architectures, which is absolutely key for edge. So we will continue to bring unmatched core density, which will again enable reducing the total cost of ownership. Our solutions are planned to be increasing the memory bandwidth and also I/O bandwidth as well. We are innovating and bringing new compute capabilities to our processor cores, to both the CPU and GPU, to address the AI and inference acceleration that is needed in the network as well. So we are bringing all of the key elements that are absolutely needed for next generation networks. Recently, at our third quarter earnings call, our CEO, Lisa Su, provided an update on our next generation device, which is codenamed Venice, which will be based on Zen 6 processors. And then again, we are improving in terms of microarchitecture to get more performance and get better instructions per cycle. What also is very important that this product is going to be manufactured in 2 nanometers. And the lower technology node you're using, you're getting benefits of getting higher performance and much better performance efficiency or energy efficiency. So we are very excited about this product. So this product, Venice, and all the next generation products that we'll bring to market will enable network equipment providers such as our partner Nokia to build cloud native 5G and 6G systems, which will be leading edge in terms of performance, power efficiency, intelligence, security, and also automation.
Excellent. Thank you so much, Piotr. So we're approaching the end of our webinar, and we've covered a lot of really good ground today. We've explored the market expectations for high performance, energy efficient networks, and how Nokia Cloud Packet Core is delivering on those expectations. So at this time, I'd like to invite each of you to share your final thoughts on the future of cloud networking and the role of this innovative solution in shaping the telecom landscape. Piotr, I'm going to start with you. How would you like to share your thoughts?
I think that I will echo quite a lot what Gordon and Ruth mentioned earlier, that convergence of 5G, edge computing, and AI is redefining how the networks are built, need to be scaled, and also monetized at the end of the day. And to me, the demands of these new ultra low latency, massive device connectivity, and dynamic service delivery, operators have to embrace the high performance, scalable, and energy efficient infrastructure. And we at AMD, we bring these compute intensive and compute efficient solutions that are pushing the boundaries of what is possible. And that enables our partners to make these new network architectures a reality.
Excellent. Gordon, I'm going to move to you. What final considerations would you like to leave us with?
Okay, Shelley, summing up, Nokia is strategically transforming its UPF appliance offerings by merging traditional appliance reliability with cloud-native capabilities, creating a hybrid approach that preserves existing appliance strengths while incorporating cloud-native agility, flexibility, and enhanced observability. We will enable a seamless migration path from VNF to CNF-based appliance through software-only upgrades, eliminating the need for new hardware investments and protecting existing customer assets. Next year, Nokia's CNF appliance portfolio, our compact cloud appliances, will introduce significant innovations focused on achieving industry-leading performance, operational efficiency, and deployment flexibility, positioning the company to establish new market benchmarks and set industry standards for the next generation UPF solutions.
Fabulous. And Ruth, what points would you like to make sure our audience keeps in mind?
So, Piotr and Gordon have mentioned a lot of the key elements, which is brilliant. But really, we can see that edge computing is really starting to grow now. There's a lot more demand for the localized performance, which I spoke about. We're seeing demand through 5G SA now. The technology's maturing. We're seeing demand from AI, private networks, and a lot of applications as well. Everyone's sort of spoken about this kind of important transition to cloud native network functions. And really that is offering these new ways to be able to manage much more efficiently, much more automated. And really the technology is now in place to be able to move towards this. I spoke about sort of energy efficiency and OPEX and CAPEX cost. Really, total cost of ownership is really important to operators. So we need to make sure that these edge platforms, that they're both intelligent, they've got this new architecture, but they can deliver the actual solutions in quite a small, compact sort of footprint that's giving this high performance. And I think, everyone on the call has sort of mentioned this a lot today as well.
So thank you to Ruth, Gordon, and Piotr for your insightful perspectives and valuable contributions to this webinar. We've learned a great deal about the exciting future of cloud networking and the crucial role that Nokia Cloud Packet Core and AMD Core processors play in shaping the telecom landscape. We hope this webinar has provided you with valuable insights and a deeper understanding of the technology driving the next generation of telecom networks. We encourage you to continue exploring the possibilities of cloud networking and to stay tuned for future developments in this dynamic field. Thank you all for joining us today. This concludes our webinar.